Good morning, good afternoon, good evening, everybody. This is LZ from BNB Chain, and I'll be your host of today. Today is a very interesting session that ChainIDE is hosting. So it'll be master classes on blockchain security, and we have two very esteemed guests invited to the session. I do not want to take up too much of their time, so without further ado, I'd like to introduce Professor Wang Zehua from University of British Columbia, and he will give you a very insightful lesson on blockchain security. Good evening, Prof. Wang. How's everything going?
Hi, thank you for the intro. I'm good. So very glad to be here.
Yeah, likewise. It's a pleasure to have you here as well. So I will let you start. Thank you.
Okay, cool. I need to find out how to share my screen. Give me a second. Share these two monitors and share. Okay, so right now I can choose my application. So could you please acknowledge you can see my sharing screen?
We can see it.
Okay, perfect. Cool. Very glad to be here, and thank you for the invitation from both BNB and Metamask. I'm Dr. Zehua Wang. I'm founder of the Verilog Audit. It's an auditing firm, and also I'm a professor in the ECE department at the University of British Columbia. I designed blockchain courses in the UBC, including the foundation of blockchain and also the blockchain software engineering. And then myself was a programmer before. I started code in with Solidity since the version 0.3, and right now is 0.8. I presently experienced the version evolution of the Solidity and the smart contracts. So I'm very happy to be here and to share some of my opinion in the security in DeFi. Okay, cool. So what's a DeFi? This is a hot topic. I think that most of the audience and in watching this video or this live stream should know what a DeFi is. But one word in the nutshell about DeFi is that it's a financial service system in blockchain. Because like we have the banks, we have those mortgages, we have those the stocks, or we can also have those options, or basically most of those existing financial services, we can build that in the blockchain by using smart contracts. And then with a smart contract, we can write down the business business logic, right? Because every people have the every person has the wallet. It can be the plugin in Metamask, or it can be the hardware wallet. Then you can interact with the code on the blockchain, and you can also transfer the tokens. Then you can stake the tokens. You can provide the liquidity, and you can mine new tokens as a reward if you put the liquidity, or if you trade on this financial platform, then you will be given some reward. So basically, then we have replicated some of those modern financial system on the blockchain. And some featured ones include the DEX, the decentralized exchange, and then we can have the very well-known the DEX, like the Uniswap, and then the forks of Uniswap in different chains, or we also have and we have different market making model, right? The AMM is one of them, but right now then we also have like the Dodo DEX. We have other market maker models, and we do have lending protocols like RV. So you can deposit some assets in the RV, like the collateral, then you can borrow some money out. We also have the bond model. For example, in the Olympus style, you can basically you can buy some the OM token, or you can also buy some other tokens by first deposit your assets, and then you need to wait maybe 2 weeks until then you will be given this the token, right? But usually then you can purchase the token by waiting 2 weeks. Then you can buy this token with a lower price comparing with the market. And we also have the option products like the Lyria or Premia. It's basically it's very similar to the option services in our current modern financial system. For example, you can you have the right, but not the obligation to buy or sell some token as some price. Okay, according to you are in the money or out of the money, then you can determine then if you want to apply your right, and then you can earn some revenue by using this option. So all of those tax, lending, bond, option, they were in the traditional, I would say the concept, they were in the traditional financial services, but now we have moved them into the blockchain by using the smart contracts. So DeFi is even better than the traditional financial services. Like most of you should know flash loan. A flash loan is that you do not even need to provide the collateral for your loan, because you borrow this money and then you will return this money directly in the same transaction. The same transaction, I mean, the same series of transactions. Yeah, so you can borrow some money from, for example, from Avi, okay, without any collateral, and you can use this portion of money in the same series of transactions to do some tradings, and eventually you need to pay whatever you borrowed out back to Avi. So this flash loan is it does not exist in the traditional financial system, because most of the case when you want to borrow money from the bank, you need to give the collateral, even like your house, your car, or some other valuable assets. But the flash loan is something definitely new in DeFi, and because of that, then we do have some vulnerabilities. It's called the flash loan attack. Later on, you will see more examples about the flash loan attack. So this is DeFi. So why DeFi is we have so many hacking events in DeFi, because in the smart contract, it saves a lot of money in the smart contract. Okay, and then we need to do some arithmetic calculations. We have those functions, and to determine what's the return rate. Okay, and then what's the APY, and then people can mine more tokens. Or if I want to be a liquidity provider, I need to provide both tokens as a pair into the liquidity pool. You can see that there's a lot of money. There is a huge amount of assets in the smart contracts, and then and then the hackers would like to use the vulnerabilities or bugs, or even the some corner cases in the smart contract to try to take the advantage from the smart contract. Okay, or get the undeserved profit from exploiting the smart contracts. So with today's topic, I want to list this 5 of the issues in the DeFi. Okay, so the first is the incorrect liquidity pool calculation. You'll see that for some of those decentralized exchange, so in the decentralized exchange, if you want to do the trade, so there must be a liquidity inside the DEX. Okay, so if I want to be the liquidity provider, I need to provide liquidity for a pair of the tokens. So if somebody is buying some the token A and then by selling this token B into this pool, basically I will be the seller. Okay, I sell token A to the token A buyer, and then I receive the token B and paid by that token buyer. So then there must be the some mechanism in the smart contract to calculate the price or calculate the slippage and to find out so what's the amount of token and should be granted after receiving the corresponding the token to be traded in. And then so some code later on you will see some examples. So you will see that if we did not calculate the correct price of this token A versus B, then some hackers can use the flash loan attack and to take a huge advantage from the pool. And we do have this situation happened in the BSC, the Binance Smart Chain, including the Pancake Swap penny token hack, and also we do have another one. It's called the Burger Swap. Okay, we had that issues happen in the BSC before, and we another category about the security is the stolen of the leaked private key. Every wallet is a private key, and from the private key, and then we have the public key. But the public key is not your address. The hash of your public key with the first 160 bits of the hashing result of the public key actually is your wallet in the EVM or in all of those Ethereum compatible chains. So as long as then you know that the private key is actually a very large value. Okay, that value is used for signing a transaction. Then if somebody takes your private key, basically the person has the total control of your wallet. You can send the money out. But why is related with DeFi? Because some of those DeFi contracts, they do have the privilege functions. Even in the Open Zeppelin library, there is the ownable interface, okay, or ownable contracts. So there is an owner and will be initialized by whoever building or deploying the smart contracts, and only those owner IDs or the wallets can change or call some specific functions. So sometimes it's good because we can do some token rescue, we can lock some malicious account, but also if this private key of that account is leaked out, then it makes the DeFi protocol be very vulnerable, and the hacker is able to drain all of those assets in the smart contract out. Okay, so another level of the security is the pro access control. And similar to this, the private key leakage, if somebody can bypass the authority or authentication check in the smart contract, then the hacker is somehow able to transfer the tokens or assets in the smart contract out. This not is also not a very pleasant experience, but we do have these situations happen in the DeFi world, and also give you some example later. And front-running attack is all the transactions will be transmitted out by using the peer-to-peer network. For example, if I sign a transaction, and then by using my Metamask, and then this transaction is first sent to the portal of Metamask. So Metamask will maintain a lot of those peers, and then in this peer-to-peer network. And then when I sign a transaction, my signed transaction is first sent to one of those access node or portal nodes of Metamask, and where this transaction will be broadcasted to the entire blockchain ecosystem. Okay, and then this transaction will not be directly mined. It will be received by other miners, and first goes into this mining pool. And those miners, according to my gas price, it will select those valuable transactions to mine first. So that's why then if you give a higher gas price, your transaction is mined first. But the front running is that, okay, if I'm the miner and I see, okay, I can make some profit, I can take advantage of mining another transaction in front of this transaction in my pending transaction pool, then it is very easy for a miner and to just inject another transaction and with a higher transaction fee than your transaction. So, and then eventually when your transaction is kept into this block, then this front runner and can take the advantage of the system and then earn money from your transaction. Okay, it's the front running attack. And the very last one, we have the rug pull and the Ponzi schemes. We do have this situation like in the history. Rug pull means that some backdoor in the smart contract enables the owner of this project, okay, or deploy or the programmer of this project steal all of the tokens in the smart contract. It's very bad, okay, and then it's just very frustrating. But we did have the situation happen before. And for all of those security issues I just mentioned, then I will give you some examples and also give you the license. So what the license we can learn from the hacking events, and then just help you to learn the best practice, or no matter if you are DeFi project owner or if you are just a personal investor, then we can learn some lesson from those hacking events. So that will be the main purpose for this online lecture. Okay, let's come into more details. The incorrect liquidity pool calculation, I just want to mention two of them. We do have more. At least in the last year, in 2021, we had 4 or 5 this kind of flash loan attack. And just put two of them here. One is a Pancake Bunny protocol hack in the May of 2021. Another one is the Burger Swap protocol hack. Yes, because I'm sharing the screen just with my Microsoft PowerPoint. If I just click this link, and then you probably cannot see the web page. So what I need to do is that I will first open the web page and then switch my sharing screen from my PowerPoint to my web browser. So give me a second. Okay, I will try to stop the sharing and let me share another one. Okay, I will put this web page in a new window and share screen. So here's this one. Okay, so I guess right now then you can see this. Yeah, this is the Bunny token hack. So the guy posts a series of study about why how this hack happens. So let's just quickly go through this, and then I'm not sure then if let me just paste this one in the chat. I'm not sure if you can click this link. I just paste this web page URL into the chat. It's a private chat. Or is yeah, anyway, then you can just remember this ID or remember this guy's name. It's Igor. So this is this is a slide describing how this how this attack happens. So this added a small number of assets to the Bunny USDT and the WBNB wallets. So this is very important. Later on, then this hack basically is try to let BNB liquidity pool believe that this person has contributed a lot of liquidity. So this person will eventually be given a lot of the USDT and then WBNB value when he removes the liquidity. But this one is about how you can make this smart contract believe that you have provided a lot of liquidity if you do not have that amount of money. That's the flash loan. How to use a flash loan is actually very easy. You can just use a smart contract, and you can just write a smart contract. And in this smart contract, you have a function. In this function, you call a bunch of other functions. right? Because all of those the DAX, the decentralized applications, they have those interface. You can just call those functions by using a smart contract, and then you combine all of those smart contracts calling in the same function. You just run that function, then everything is well triggered together in the bunch of transactions or a series transactions. So it's first borrow some, you can see that it's borrowed a lot of money from the flash loan. And then it's borrowed this WBNB, a lot of WBNB, and also it's borrowed some the BUSD. It's just the stable coin in the BSC. It's a lot of money there. And so right now, this person has a lot of BNB and a lot of USDT in Binance Smart Chain. And so it's at not all of those borrowed BNB. The person add 7.7K BNB, and then all of those borrowed USDT, and to provide the liquidity to the USDT and WBNB pool in the PancakeSwap. So it provides a lot of liquidity to this PancakeSwap liquidity pool. And then it's swapped to 2.3 because you can just roughly count the borrowed amount of BNB. It is far more than 7.7K. And for the rest of those BNB, not yet put into the liquidity, it will just sell all of those BNB for USDT. So it's just dump a lot of BNB into this pool. So it will change this, it will basically drain out all of the USDT inside the pool. And the BNB inside the pool, it goes very large. Okay, and this means because it's put a lot of it did a lot of swapping, then it means the 7 million money, and using a set from the first step, because of the extra the liquidity, the RP tokens in the PancakeSwap pool, the Bunny Finance believe that this exploiter added a large amount of BNB. So this is the most important step in this hack. Then eventually it shows the 4.8 million Bunny and the 2.3 million WBNB, and then this is 2.9 million USDT, and then pay all of the flash loan back. So you can see that it takes out the flash loan and directly save all of flash saves back. Okay, repay the flash loan in the same block. Okay, it's actually just the same transaction because it's write all of those transactions in the function of the smart contract, maybe. Okay, and then eventually you can see that. So why this flash loan can change this price very much? Because there is you can see that this is the function. Eventually, it actually is mint for V2. It's mint for Bunny. It is the minting contract for the Bunny token. And then in this one, the first argument is the number of BNB and the Bunny BNB token. And this one goes into this argument is the assets. But eventually you can see that this is the pancake pair with this address asset total supply, because this person has deposited a lot of put a lot of assets into this address. So this value goes very large. When this value goes very large, and then this value in the BNB is very, very small. So this is the found by the pack shield. And then the root cause was that the hacker could manipulate the Bunny minting price. So if this Bunny minting price is very low, then this person can mint a lot of Bunny token out. Okay, so this is the very general description for the first hack. Then we are learning today is the PancakeSwap Bunny hack. Okay, so let me come back to the other one. So the other one, it is this burger swap protocol hack, but it is exactly the same routine. Almost. I probably cannot say exactly the same, because in the burger swap protocol, the hacker creates a fixed token, and then use two token pairs. Okay, and with the fake token as the middle, as the median. Okay, so it can still manipulate the price of a valuable token. Okay, let me just quickly go through this. Okay, is the burger swap. Okay. So unfortunately, this burger swap is also on BSC because today is the BSC session. So I would like to introduce some these events in BSC. Almost the same logic. Okay. Okay, you can see this. Okay, by adjusting this routing, the hacker creates some burger token. Burger token is the native token of this burger swap, and then to some fake token, and the fake token to this the wrapped BNB routing, and then through the burger to the fake token trading pair attacker, and then can re-enter this burger swap through the fake token and the manipulated number of reserve 0 and reserve 1 in the pair of contracts, causing the price to change. And so here is the main step. So using the wrapped BNB and as the example to illustrate the details of this hack, hacker flash swap this 6,000 WBNB 2 million, and from the pancake swap, and then swap almost all the WBNB to the 92,000 burger to burger swap. And here's a detailed transaction events and monitored, captured from this the BSC scan. And eventually, it's just eventually that in total, hacker receives this 8,800 WBNB, and then swap this 493 WBNB around this value of a burger, and eventually pay back all of flash loan. So the flash loan attack is basically try to take the advantage of smart contract code and to manipulate the price of the tokens, okay, in the liquidity pair, and with that, the hacker can make some profit from this hack. Okay, I see there are some chat in the chat room. So, LZ, so is there any problem about the screen sharing?
Nothing at all. Please continue.
Okay, thank you. Yeah, so what's a lesson that we can learn from this previous two hacking events? So those are the lessons. So for this for the burger swap hack, so it's mainly involves ensuring that hackers should not manipulate the exchange rate between the different tokens on the protocol. Both of those hacks using this vulnerability in the smart contracts, and to prevent this, the Bunny protocol, and while no longer calculate the value of a swap internally, instead they plan to use the Chainlink contract in their token price oracle to determine a fair price for each asset. It's very important because if you just purely determine the price with your local domain, then so what's actually the flash loan attack? It's nothing more than an arbitrary trading, but the hacker just manually produce some arbitrary trading opportunities. So by using the flash loan, and the hackers can just produce this kind of arbitrary trading opportunities, and then use this opportunity, and then this hacker produced to attack this smart contract. To avoid this arbitrary trading, you would like to know the fair market price of the token, not just use the local algorithm to determine this token price, which is very traditional in all of those the automated market maker, right? Because we are using the inverse function and to calculate what's the price one the token versus the other one. So it is actually very normal in the traditional decentralized exchanges. So using some oracle like Chainlink to have the fair market price is actually very useful to avoid this kind of attack. And this use of internal price oracle is a common mistake in DeFi that has resulted in a number of expensive hacks against these protocols. Identifying and eliminating errors like this is a critical part of a security audit of the DeFi smart contracts, because the liquidity is actually the foundation of the DeFi. Okay, we know that, because without liquidity, then we do not have the DEX. Okay, without the DEX, then it's meaningless to have the lending protocols. So anyway, so this is the first lesson we learned and from this incorrect liquidity pool calculation. The next one is a little bit easier than the previous flash loan attack, the stolen and leaked private key. There's an event in 2 years ago. Actually, it's just not almost 1 year ago. It's December 14th. Nexus Mutual report a hack targeting its CEO Hugh Carp. And so this is this hacking. So this hacker that steals this CEO's private key in these 3 steps. First is the hacker gain the remote control of the CEO's computer and use this remote control access to change out the Metamask extension within the CEO's browser with a malicious version. So it's very crucial for your DeFi investors. Make sure then your MetaMask is the correct one. Do not use any MetaMask then download it from the third-party website. And using this malicious extension, the hacker was able to change the transaction and being performed and signed by the Carp to one that sent the native token to an hacker's control address. So this is the address. Give me a second. I shall show that in the. I think it should be clickable. I'm not sure why this link is not clickable. But let me just paste that into my web browser. I'm still using this one. And then I can share a screen and share this window. Okay. So this is the link, and then in my slides. So you can see that this is a fake phishing. This is another I just give this address attack. So this happened in 2020, December the 14th. This is the hacking event. So cause the person, the Carp has already transferred the token to the malicious address. So the hacker can just steal all of the token out, and it has been reported and has been analyzed. And this has the tag is a fake phishing accounts. Okay. Okay. So after stealing these tokens, the hacker began using this one exchange to convert it to the Ether. Because if one person has still a lot of the ERC20 token, and then it's better to just swap the ERC20 token back to Ether, which is the native coin in the Ethereum. So it's free to transfer this Ether out. So what's the lesson that we going to learn this? So if you are a DeFi user or if you are a DeFi developer, try to use the hardware wallet. The MetaMask it can generate some private key as inside the extension, and you can easily communicate with those blockchains like the BSC or Ethereum blockchain, or all of other blockchains. But the hardware wallet is just more secure. The reason is that the private key for your extension for the MetaMask saves your private key. If some malicious software or some hacking technology may be able to steal those private key from the extension, if somebody got your totally remote control of your computer, then the private key is just leaked out. But the hardware wallet is something different. The entropy on the hardware is just unique. And with that entropy, and your hardware wallet can produce those private keys. And your private key is never leave from your hardware wallet. And so and whenever a transaction need to be signed, the transaction data is transmitted to the hardware wallet, is signed there, and transmit the signed message out back to your computer and send it to the network. So this makes your hardware wallet much better, much safer than your MetaMask. And then right now, most of those hardware wallet users, they use the Trezor, and then they also use the Ledger. So personally, I have both of them, and then they use the experience of using both kind of hardware wallets is very similar. It's very easy to use, and you also can set a password for your hardware wallet. It's the better way to protect your crypto assets. Okay, so this is the lesson we learned. So just try not using the MetaMask. So think about this problem here. Okay, if the transaction is signed by using this the hardware wallet, okay, then definitely the MetaMask cannot be even though, okay, so your MetaMask cannot change the signed information. But yeah, so if the hacker changed the original info or the raw message to be signed, then it's another problem. Then even in that case, yeah. So if, for example, if I were a hacker, I can change the raw message, okay, to be signed. Then I can also change the recipient address. But anyway, using the hardware wallet is somehow then can reduce the vulnerabilities or reduce these kind of risks. And we have another kind of attack is a poor access control. Many DeFi smart contracts include privilege functions, just like the ownable, okay, and you have the owner. And in some cases, these access controls are missing or implemented in a way that allows an hacker to bypass them. And some recent examples of such vulnerabilities are the Poly network and Pong protocol hacks. We do have those links given here. There are two functions inside this is cross-chain data contracts. The first function in this contract is the put current epoch is some function named the public key bytes function, and this function then can be executed with a call to verify header and execute transaction in this smart contract. So the main purpose of this hacker is that the hacker sends a special formatted command to this function, and which reassign this keeper role to them. And from there, they could join the value from the protocol. A detailed explanation is given here. So let me just paste this into the chat. So due to the limited time, I cannot go through the entire article in Medium. Windows tab is okay. It's here. So the root cause of Poly network being hacked is the article here. So if you're interested, you can just pay attention to this. But the detail of the hack, just go through this quickly. Okay. The core of this hack is that this function is function of this smart contract, and it can access specific cross-chain transactions through this execute cross-chain transaction function. And since the owner of this contract, this contract is ownable. The owner of this contract is this manager contract. So it can be done in two ways. One is I can use this contract to deploy a contract like this of this Ether cross-chain data contract, or I can just transfer the ownership to this Ether cross-chain manager contract. And this manager contract can modify the keeper of the contract by calling this function and then inside this contract. And the verify header and execute transaction function of this manager contract can perform user-specific cross-chain transaction by calling this cross-chain transaction function internally. So the hacker only needs to pass in the careful constructed data through this verify header and execute transaction function for this cross-chain transaction function. And then this transaction, and to execute the call to this Ether cross-chain data contracts, and then it can eventually to change the keeper role to the address specified by the hacker. And after replacing this address of the role keeper, the hacker can construct a transaction at will and withdraw all the amounts of funds from this contract. It's the Polygon network hacking event. Another one is the Pong protocol. The Pong protocol attacker exploit access control issue within the project smart contracts using the delegate call to run the project's initialize function. And the hacker was able to change the forged address on the smart contract to their own address. This is a vulnerability inside the smart contract, because in this smart contract, the people can use this delegate call to initialize this contract by using different arguments. So still, give me a second. I'll quickly go through this. Okay. So I can just say the contract when the hacker given this and this now this hacker Okay, so let me just put this in the chat in case that somebody can just copy this. Hidden from the pool, if not, I can, okay. Yeah, so this is the attack about yeah, so this is the Punk protocol fire launch instance report. So what's the lesson we're going to learn from this two hacking events? So the lesson that we learned from this poor access control is that auditing is very necessary. So both of the vulnerabilities you have seen in this the Pong protocol and also in the previous attack, those issues can be found by the auditing. Okay, so by using the auditing, so people can find the vulnerability in the delegate call And then you can also find that if the vulnerabilities of the cross-chain transaction and can be the target of those exploiters. And another way is to further is using the multi-signature wallet, like the Gnosis. Because if you have this owner, just a person's private wallet, okay, or an individual's wallet, and then basically it is still very vulnerable. Okay, maybe this wallet is just lost. We cannot just say, okay, this person just executes those transactions purposely, but sometimes if this wallet is lost and then this some people get this wallet, and if the wallet is not with a password, then it can be used maliciously. We can use the multi-signature wallet. Gnosis give you the very good interface, and for example, 4 or 5 founders, and then can create multi-signature wallet, and then you can use this multi-signature wallet to interact with those ownable smart contracts, and the owner of those smart contracts is actually your Gnosis wallet, and you can specify what are the ratios of the founders need to sign until this transaction can be executed. So for example, if you have 4 founders or the 4 stakeholders of your project, you can specify 3 over 4 so that out of those 3 persons, they can sign this multi-signature wallet by using their Metamask or using the hardware wallet, as long as this threshold 3 over 4, right? As long as the threshold reaches, and then this transaction is sent from this multi-signature wallet. So it makes your project be more secure, and then you do not need to worry about one person hacked your entire project. Okay, and then also build more faith to the community, because community is so important. And then if you build a project saying that, okay, my project, all of those the owner's privilege functions can only be executed by the Gnosis in the multi-signature wallet, it is more trustworthy than one single person's personal wallet. And the front-running attack, I think I shall be quick because we have another couple of slides and to go, but we have just 10 minutes. Front-running attack, blockchain do not immediately add transactions to the distributed ledger, just as I explained in the beginning of this slide, of this lecture. The transactions are broadcasted to the blockchain network as soon as they are created but are stored in the memory pool on each blockchain node until they are added to the ledger as a part of this block. Okay, and then I said that if you have the higher gas price of this transaction, then your transaction will be chosen with a higher priority. The gap between this creation of the transaction and its inclusion in the ledger creates an opportunity for the front-running attack. In some cases, it is malicious, while in some other cases, like the example I'm giving you today, is the Dodo DEX or the Crypto hack about front runs and attempt exploits and then return the stolen token to the exploits protocol. So it's something good. So the person returned this stolen the tokens back. The hack against this Dodo V2 crypto crowd pooling smart contract took advantage of a flaw in this mint function of the contract. So still this initial function. This flaw allowed this function to be called multiple times with different parameters. So somehow a little bit similar to the previous the crypto the Punk network, the Punk protocol. Let me just skip this. You can just Google these buzzwords and you can find that Dodo DEX smart contract hack. And then what's the lesson that we're going to learn from this front-running attack? So access control bugs are the major issue. Implementing proper access control is essential for smart contract security. And these vulnerabilities will likely have been detected or they remediated during security auditing. So auditing becomes the standard way or standard routine when you launch a DeFi protocol. Okay, no matter what's the chain you are launching your protocol, it can be in BSC or in Mainnet or in Polygon or in Avalanche. Okay, so it is or in Oasis ephemeral paradigm. So no matter what's the chain, but having your smart contract undergo the security audit is very, very important. Okay. And very last is the rug pulls and the Ponzi schemes. So in some situation, DeFi users are the victims of the hacks from developers and the owner of the protocol themselves. The rug pull are the regrettable or fair common form of an inside attack. So someone inside a company with the privileged access to its contract uses its access to drain value from this protocol. And one we have one example is the Alpha Crypt. Okay, it's a rug and pull. So this it happened in the last year, April. So at that time, then one of the founders and saying that thing reported the case to the investors, but informed them that not contact the lawyers or law enforcement, as it would delay the recovery process. It's definitely lying. And then the investigation by the firm found that much of the cryptocurrencies invested by the exchange had been extracted and sent through the tumbler and the mixer to make this more difficult to track. So what's the lesson we can learn from rug pull is to be wary of verification. So you know that no matter what's the chain in the Ether scan or the BSC scan, we do have the verification. And then with the software engineering, then we can directly verify a smart contract by using this hard hat. Hard hat is the node module, and then you can just install the hard hat by using the npm, or you can also use the Brownie. Brownie is similar to like the hard hat, but is used in Python. So hard hat or brownies can easily verify or deploy the smart contracts. And when you have the smart contract deployed and verified, then as the user of the DeFi protocol, as an investor, I need to check out if this code has any backdoor inside that. So it somehow requires the investor or DeFi user understand the code, but at least as DeFi user, you need to mind the auditing report and make sure this code has the same hash value with that hash value hashtag in that auditing report. So it's make sure then the auditing report audited the same code and being used or being interacted with your wallet. And these vulnerabilities will likely have been detected and remediated during the auditing security audit. Okay, and then other projects also rely upon the unverified linked libraries. This means that this contract would also include the malicious backdoors. Make sure this smart contract only use those standard libraries, the Open Zeppelin libraries, or those libraries released by those big name auditing firms or the well-known security companies. Before investing in or approving any crypto projects, it's important to do your research. And then right now, and you may receive a lot of garbage tokens. So, for example, you do have some Ether and in your wallet, or you do have some BNB in the wallet of your BSC. You may receive a lot of those garbage tokens. Don't interact with any of those garbage tokens. Okay, do not approve anything because it seems like you approve to spend some garbage token, but actually the smart contract may ask you to approve some valuable assets like the BNB or the BUSD. You actually do not know if you do not check the smart contract. You do not know what's the approve function. Okay, is applied on which token. Okay, if you apply this approve for some real token or valuable token, then that you may suffer the loss. So some other materials for the developers in DeFi, we do have some the known attacks in the released by the consensus. I think I need to show this a little bit. I know it's about the end of this presentation, but just give me a couple of seconds. Share with this. Yeah, so this is the web page given by the consensus. It's the known attacks, the reinsurance attack. I think the most of you know the reinsurance attack, and you can just use the non-reinsurance modifier inside the functions for the token transfer. So it will stop the reinsurance attack, and then from running attack, and denial of service attack. So those are the very known attacks. Have been detected, and then you can easily avoid them by applying some modifiers or be mindful for the smart contract programming. Another is the very last one is some tools for the security. Okay, if you are a DeFi developer, you should also know that. Okay, so those tools are used for some basic check. Misreal is a good one. And then besides, there are also, I did not mention, it may not be mentioned here, it's called the Echidna. Okay, Echidna is ECH, let me just say. Sorry. Okay, so Echidna is another tool. It's actually the fuzzing tool. Then you can try to use this Echidna and to test some vulnerabilities or the flaws in the smart contract. Okay, and then we also have another one. It's called a Slincer. Okay, Slincer is give me a second. How spell that? Slicer. Okay. Yeah. Anyway, so it is. It's almost the end of this presentation now. Yeah, so RZ, so is there any questions and then I can take?
Sure. So, Dr. Wang, I'd like to know a little bit more about the hack that happened recently, right? OpenSea, the NFT hack. Are you aware of it?
OpenSea attack?
Right. It just happened yesterday, I believe.
Oh, okay. Sorry, I did not. I'm not quite sure. I will check that. So could you please introduce that a little bit more?
Sure, no worries. Basically, there's this malicious contract, and like you said, there were some signatures that users signed, and that led to their wallets being open to vulnerabilities. So I agree with what you said, and I think your sharing was very insightful. So we can move on from that, I think. So could I also know a little bit more about Verilog auditing?
Oh yeah, so the Verilog auditing is a firm then that offers the smart contract security services to decentralized applications. So I'm the founder of this Verilog. And then this the entire Verilog auditing team is coming from the smart contract developers. We all of us had worked with a lot of DeFi protocols and developed a lot of DeFi smart contracts. And the team at Verilog understand the need of smart contract developers and developed a better aligned auditing business model. And we work with our customer closely. Okay, it's different from other auditing teams. So we directly talk with our customer, and then we have the daily about those the bugs or the the vulnerable codes. So give them the daily update, and then we are also very responsive for any concerns. So this is the very log auditing. And I do have this website. Let me just put the website in the chat. So if possible, and you can share this link to the audience. Thank you.
Sure. Thank you so much for gracing us with your attendance today. So
Thank you,
without further ado, thank you. So this is a very great session hosted by Dr. Wang, and I believe the audiences would have learned a lot from him. So without further ado, let me go into the next guest. We have someone very special, Mr. Malcolm Larida, who is the Overseas Strategy Director at BSC. So, hey Malcolm, how's everything going?
So good evening, everyone, or good morning, depending on where you are this day. My name is Malcolm, and I'm the Overseas Strategy Director here at BSC, a blockchain security company. I'm here today to talk about smart contract attacks and how we can prevent them from happening. In this presentation, I will first explain a few common security risks that we are faced with when developing smart contracts. I will also show you a free-to-use scanning tool that we call Verification as a Service that we have developed here in-house at BSC. It's free for anyone to use, so if you are a developer developing smart contracts, then I strongly suggest that you hang on to this presentation to at least see the demo that will be showing a little bit later. And after that, I will introduce formal verification. And that's a methodology that we use in our security audits. It's basically a mathematical proof that the smart contract code is correct. And we also integrate that in our verification as a service tool to be able to cover all the business logic. I will show a demo on that part as well. And then at the very end, I will show an example on what we provide to our clients in a security audit report. And we will wrap it up with a short Q&A session. So first, let me do a very short introduction to our company so that you know who we are and what we do. So BSC is a leading global blockchain security company. We are founded by several professors from world-renowned universities. The team consists of more than 100 security experts, whereas more than 40 of us are PhDs and postdocs. So we have very strong expertise in cybersecurity. We have audited more than 2,000 smart contracts and more than 50 different public blockchains worldwide, and successfully protected nearly 10 billion USD worth of digital assets, and recognized by global market leaders. So let's jump into smart contract attacks. We had quite good coverage of attacks during the last presentation. So as we know, smart contract put laws into code. It brings us trust, economy, efficiency, and many other benefits. It is widely used in digital payment, digital asset management, multi-signature contracts, cloud computing, decentralized organizations, and more. It brings us benefits, but it also introduces new risks. There has been many cybersecurity issues in smart contracts, resulting in digital assets aggregate of billions of US dollars being stolen or lost. Especially in 2021, last year, with the popularity of decentralized finance, we see more digital assets being managed directly by smart contracts. So this also introduces a higher incentive for hackers to try to attack these smart contracts. A few examples that we saw last year was Poly Network, Cream Finance, and Compound, with Poly Network losing more than $600 million and both Cream Finance and Compound losing more than 100 million each. And as you can see here, each of them were attacked by taking advantage of completely different vulnerabilities. It's sort of puts emphasis on the importance of doing rigorous security auditing to find vulnerabilities before deploying smart contracts onto the chain. On this slide, you can see that the decentralized finance related events rise quickly. And as mentioned, it's much because of more digital assets being managed directly through smart contracts. And the incentive it brings in turn for bad actors to perform attacks. So while smart contracts do deliver value, a very small bug can result in huge losses. Smart contracts cannot be modified directly after deployed. So that means that if the code has bugs or any faults, then it is likely to be exploited sooner or later. Smart contracts have a very low fault tolerance rate. So here are some of the risks issues in smart contracts that differ from traditional software applications that the developers might be more familiar with. It's basically new attack vectors that we need to keep in mind. And first one is that defects are hard to fix. So blockchains are decentralized and tamper-proof. Smart contracts cannot be modified after they have been submitted to the chain. If a defect exists in a smart contract, then it will also persist. There is no way to shut down the servers or revert data changes as you may be used to in traditional software. Another added risk is that public blockchains are open system. Anyone can view and interact with the code on the blockchain after it is deployed. Contract transactions and data may be visible to counterparties. So this leads to the fact that smart contract vulnerabilities are relatively easy to identify and exploit, as anyone can read the source code directly. At the same time, running smart contracts, the data stored on the chain is publicly accessible for anyone. So privacy and other sensitive data leakage should be prevented when dealing with private data. We also need to acknowledge that there is immaturity in blockchain platforms and smart contract language. Distributed application development is different from traditional application development. Developers of distributed applications need to have a thorough understanding of operations on the blockchain. Otherwise, the intention of the developers will be inconsistent with the actual execution of the smart contracts. So in addition, the current common blockchain platforms are constantly developing and evolving and upgrading, so various functions will change as the version changes. So when you upgrade a platform, you need to evaluate the difference between the original smart contract and the new version of the platform to make appropriate adjustments and to avoid security risks. This is also coupled with the lack of security awareness and smart contract development experience of software developers. So many software developers are very familiar with traditional software security, but with limited experience in developing smart contracts, there are many attack surfaces that they are not aware of, and also in how the compiled code will actually perform in the live environment. And it's also about the habit of asking for a professional third-party audit, which is somewhat lacking in the smart contract development industry as well. It is also related to digital asset. So smart contracts are used to store and move digital assets with a monetary value, and that value can be quite significant, especially in decentralized finance. Security issues in smart contracts can lead to big financial losses, both for the deployer of the contract and for the application users. So So as a result, the risk of security problems in a smart contract is typically greater than what you see in traditional applications, where transactions most often can be reverted. And on public blockchains, transactions are public, of course, but the ownership is anonymous, so you will rarely be able to trace down the attacker if something would happen. So continuing on sources of risk, as we mentioned, the code is often open source and available to anyone, and this generates attack surfaces that we might not be used to. It attracts more hackers when the incentive to attack a smart contract increases in monetary value. And it's worth to mention also that it attracts hackers both with good intentions and malicious intentions. So there are many white hackers out there as well that want to help the industry, but there are also many hackers with malicious intentions. So we want to make sure before we deploy a smart contract that it is secure. And here are some of the common vulnerabilities that we see when working with smart contract auditing. We have re-entrancy attacks, integer overflow attacks, parameter manipulation, self-destruct attacks, and incorrect token output calculations. We had a quite thorough walkthrough of different attacks in the last presentation here. So maybe I just mentioned two of these and how they usually end up in smart contracts and how they are attacked. So the first one is as a re-entrancy attack, and that's basically a way to invoke smart contracts in a manner which would give the attacker more access than he should have. We can do a very simple example. So smart contracts need to implement checks in their function to confirm that the person who invoked the contract have the correct privileges. And this often needs to be done several times when interacting with a smart contract. A very simple example would be, let's say, just transferring a token. So if the user is invoking the smart contract, then there will be a check at accessing the smart contract if the user have sufficient funds or not. But let's say that there is only a check when accessing the smart contract and not an extra check when actually sending the tokens. Then this could be abused by the attacker invoking the smart contract several times without sending the tokens, basically passing the first check on how much funds that the account has available. And if there is not that extra check at sending time, then the attacker could send the transaction, several transactions at the same time, because the first check is already passed, and thus overdrafting his actual balance and draining the smart contract. And this is a very simplified example. There are much more complex interactions where you have smart contracts interacting with each other and more complex interaction in access rights. And then we also have integer overflow attacks, which most developers are familiar with. And this is also a big issue in smart contracts, because in smart contracts, we want to optimize the gas usage. So variables will be assigned the minimum size that they need to have for the contract to operate correctly. That means that overflow and underflow needs to be taken into particular consideration. Basically, it means that if you do operations on integers within the smart contract and it gets manipulated to above the maximum integer value, then the integer will restart at the minimum value, or the other way around, an underflow on the minimum value into the maximum value. And this can be used to manipulate the access right and token balances and accessible funds to the attacker. This is also something to take into particular considerations. And all of these attacks and vulnerabilities written here are vulnerabilities that are difficult to identify by just reading the code. They are not that straightforward to see unless you do a very thorough security audit. And there are many more attacks than these. So to mitigate these attacks, we need professional security auditors and automatic scanning tools. So we have developed our own tool here at Biozin called the Biozin Verification as a Service, or VAS as short. And I would like to show you a very quick demo on what it looks like and how easy it is to use. And it is free to all developers to use as well. So if you are interested in just running your smart contract through this platform, then you can do that as well. So let me just see if I can open up my sharing screen here. And if I may ask the host to switch over to the shared screen right now and get an indication that it is correct. So can the host, can you please switch over to my shared screen, the browser? Thank you. Here you have our homepage. You can access it by just navigating to biozin.com. And this is the site that you will see when accessing our website. And here you can click on our platform, Verification as a Service. And you can try it out for free by clicking this button here. You will come to the login screen, and let me see, I have my login information already entered onto the screen, and the verification code is just to calculate the little math problem that you have in the screen there, and log in. And this is how the platform looks like. You will have the source code in the middle and some settings that you can set in the right side of the screen, and smart contracts on the left side. So here we have a smart contract on a regular ERC20 token. At first sight, it might look quite ordinary. There's nothing strange. It has a transfer function. It has balance of approval and so forth. So the first thing we want to do is to look at the version that this smart contract is written in. So it's 0.4.24. And so we want to tell the Verification as a Service tool to compile this code at the same version or slightly above it. So we have a list of versions that we can compile in, and we do have the exact version here. So let's pick that one. And we also need to tell the compiler on what it should do the verification on. So we want to run it on this test token contract. So we will paste it in here. And then we simply click on the started detection, and it will take a few seconds to run this verification. So let's just hang on a bit and see what the result will be. And here we received very quickly a full list of vulnerabilities in this contract. So for example, we can see block parameter manipulation here. So you can just click whatever vulnerability that is fine, and it will display it directly in the source code with a short feedback down below. We can see an integer underflow, which we talked a little bit about over here. We can see an integer overflow, two of them over here. We can see a possibility for the contract to be invoked with self-destruct here. We see a reentrancy or possible reentrancy vulnerability here. So even though at first sight, if you do a manual audit on this code, everything might look that it's perfectly fine. But by using our developed Verification as a Service tool, you can easily see that there actually do exist quite some issues that you need to take a closer look at. And our tool is updated continuously. So as soon as there are new vulnerabilities found by the blockchain community, those are added to our tool as well, so we can rerun the platform both on old and new code to also check against the new vulnerabilities that are found. Okay, so let's switch back to the presentation again, the PPT. Thank you. And then we also have unknown interaction vulnerabilities. So that's more complex interaction between different smart contracts that may not be that straightforward to find if you just look at a simple app or a single application individually, but where you need to take into consideration how the smart contract and the application interacts with other applications. And this is quite common also in decentralized finance, where you have many different DeFi protocols that can interact with each other. For example, you have these lending protocols, and you have decentralized exchanges. You have also leverage trading directly on chain and so forth. So to give an example on the complexity of this, we will look at one of the attacks that were done last year, which was a flash loan attack. This is a graph to illustrate how that flash loan went through, and it was quite complex to identify, and the attacker was quite creative in constructing this scenario. So this is a constructed scenario that the attacker thought of. It started out by the attacker doing a flash loan. Sorry, we may have to do a quick restart here again. Sorry, the computer went black here again. I'm soon back again. So the issue that I'm having over here, just to bring everybody up to the same page, we have a small overheating issue at the laptop. So the computer, it's using quite a lot of computer power for this presentation technology here. So the laptop gives me a black screen when it gets too hot here. Hopefully that should be all problems for this presentation, just so that you know what's happening. Okay, so to go back to the attack that we had, the attacker borrowed 10,000 USD from the 10,000 Ethereum from the DYDX protocol. And then they split it into, and then they split it into two parts. They sent one part to the Compound protocol and another part to the BZX protocol. On the Compound protocol, they used the Ethereum to do a borrow against wrapped Bitcoin. And on the BZX protocol, they did a similar thing, but they used the Ethereum to take a leverage short position against wrapped Bitcoin. So they actually received a value 5 times the worth of their Ethereum in wrapped Bitcoin instead. So they leveraged the flash loan of 10,000 Ethereum to get an even larger amount of wrapped Bitcoin. They transferred this wrapped Bitcoin to the Kyber network to trade it against Ethereum. And the small, well, not so small issue that the attacker took advantage of here was that the liquidity of the Kyber network at that point in time were relatively low. So there was a quite big slippage when trading wrapped Bitcoin against Ethereum. And Uniswap also takes its price feed from the Kyber network, sort of like part of its oracle to set the trading rate between wrapped Bitcoin and Ethereum. And Uniswap liquidity at that time was very, very good. So the attacker, since he himself or herself knew that the Kyber network slippage would temporarily affect the trading rate at Uniswap, he took advantage of that short time window to trade back his wrapped Bitcoin into Ethereum and thus gain more Ethereum than the wrapped Bitcoin actually was worth, much because of the Kyber network slippage. And then he could just simply trade these or return the Ethereum he borrowed back again and end up with a profit of 1,271 Ethereum. So this is a quite complex scenario and constructed scenario from the attacker's side, where he knew that if he took advantage of these steps, then he could end up with a profit on the cost of the protocols. All right, so that's where we at Biosin come into the picture. We are a professional blockchain security company, and we fill in the gap between smart contract expertise and smart contract audits. So we have audited more than 2,000 contracts. As we mentioned, we have more than 100 security experts, whereas more than 40 of us are PhDs and postdocs. We are experts in all of these common vulnerabilities. As mentioned, our verification as a service tool gets updated with new attacks. It's easy to get an overview of what vulnerabilities there are. We are experts in dynamic vulnerabilities. So for example, function visibility, contract limit bypass, call stack exhaustion, and all of these are also included in our verification as a service platform. And lastly, we are experts in formal verification. And this is a quality assurance method that is used in most critical systems. So for example, the Mars probe control module and in many metro control systems. It's a very, very rigorous testing for quality assurance. And we stand out by having our own in-house experts in formal verification. So what we do is, of course, we have these different tools we can use to make sure that the contract is secure. We have the static analysis and scanning, which is fast, but it is prone to false positives. So as you can see in the small demo before, we get a list on possible vulnerabilities, but it could be false positives. So we need to have our own experts to go through this report and all the issues one by one to confirm the issues reported. We're also experts at dynamic analysis and testing, so that one is very precise. And by looking at the runtime, we can see how the contract code actually executes, and thus we can easily find these positives, but on the other hand, it gives false negatives. So just because we can ensure that the execution is running correctly, it cannot be said that there 100% does not exist any vulnerabilities whatsoever. So that's why we also have this formal verification, which is very rigorous. It's to prove correctness. So it's consistency between the design requirements and the implementation. It's a mathematical method. A formal verification can effectively determine whether the code of a program is correct. And correct in this instance means that the program runs completely as expected. That then actually ensuring completely that there is not a single unexpected execution path. That's also one of the areas where our company really stands out by being experts in this area. So why do we need to do these formal verifications? Well, the flash loan attack that was explained just recently, we can see that there can be maliciously constructed scenarios that we cannot see by looking at just the code itself. And there could be errors triggered by a large number of what we call impossible events. So events that cannot happen, but if the situation changes through some unexpected scenario, then these vulnerabilities can suddenly occur. I will show you a short example on that also in a little while, also using our verification as a service tool. So by using formal verification, we provide a complete coverage of all the boundary conditions without to first have to manually identify all the possible test scenarios or test cases. And it proves that the actual execution of the program meets the expected behavior. It's way beyond what specified test cases can provide. So normally when you construct test cases, you will have specified scenarios around the boundary constraints to see that the program will perform as expected around these constraints. Whereas in formal verification, we will actually test every single input that's possible and confirm that satisfied the specification. It's a little bit similar to fuzzing, but it's better than fuzzing since it's not random generation, it's actually complete coverage. And as mentioned, the testing methodology is so rigorous that is used at the key quality assurance in the Mars probe control module in Metro control systems, and it's also the main quality assurance methodology used in Microsoft. So let's do an illustration of how it works with formal verification. The first and hardest step is to actually write the formal specification, the specification block in the top left part here. And that's why we have our own formal verification experts in-house here to write these specifications for our clients. And this specification is what the code is supposed to do, and not on how it does it. So it looks not too much on the implementation, but actually on what the code is supposed to do. And these properties will be described in rigorous math logic. Then on the second step, these specifications are added to the smart contract code as an assertion. And we can add it to our verification as a service platform to verify the code against these specifications. And more often than not, when we do these verifications, we will find bugs in the code. It happens more often than not. So this visualizes the importance of doing a formal verification. And then, of course, we have sufficient time to fix these issues during the course of the project. And when fixed, we can run it again, and the solutions will also be proved correctly by this formal verification. So it's a sort of peace of mind for the developers to prove that the behavior completely meets the specification. So let's take a look at an actual code snippet here. So this is from a game on Ethereum. It's two wizards that can duel each other. And the basic idea on the duels are that the winner will, if they defeat the opponent, the winner will take the power from the wizard. So each wizard have their own unique power. Some wizards have multiple powers, and once they defeat the opponent, they will inherit the power of the opponent, and the opponent will be completely removed from the game. So the winners of the duels will get more and more powerful as they gain more and more powers. And when this game was released on Ethereum, there occurred some unknown logic flaw. So it turns out that someone on playing this game were wiping out the game assets. So both wizards and powers were being removed from the game completely, which shouldn't be possible. And to find out how this happened, we added our formal verification across the whole game, across all the smart contracts on the game. So we will take a look here at this particular code snippet, which is one of the snippets where we did this formal verification. And this snippet is called resolve time.dual. It's used to handle the result if there is a timeout in the battle. So what we need to do here is to ensure that the functionality or the bounded resource is correct. So we don't really care too much on how it's implemented here, but the bounded resource needs to be proved correct. And the bounded resource in this particular example is to make sure that powers cannot be created out of thin air. And they can also not disappear without being transferred to a new wizard. So that's why we added this assertion at the bottom here at this page to ensure that the powers of the wizards that enter the game need to also exist after the game. So let's go back. So by adding this small assertion, let's see how it looks like in our platform. So let's share the screen again. And if the host can help me to switch over to the browser again, thank you. Here we have the code that was at the presentation, the same game. So we will do the same thing here again. We will copy the name of the contract into the right side of the picture here, and we will look at the version number of the smart contract and choose the correct version. We can actually choose the latest version here. And as you can see, we have added the bounded resource at the bottom here to see if there is any assertion errors in this code snippet. And as mentioned, these assertions will be done in all the function and all the smart contracts across the whole game to confirm that there are and that all bounded resources are correct. So it's running a detection right now, and we receive an assertion error. It shows that this assertion is not correct. There are some scenarios where this will not be fulfilled. So this is where we need to go and look into detail into the code snippet. And once our security auditors did go into this code and looked into detail, they found the edge case that if the two duels or if the two wizards that were provided into this function were the same wizard. So if the wizard 1 equals wizard 2, so the wizard duel himself, more or less, then you will end up in a situation where the winner gains his power from himself, and then he also removes himself from the game completely. And when he removes himself from the game, then the power is also removed from the game. That means that this assertion will not be fulfilled. And to fix these security issues, what we need to do is add this line of code here. Require that the two wizards that duel each other is not the same wizard. And then we can go back and we can do the same thing again. We add this line of code and we run the detection and we see if our assertion is fixed here. And there we go, no issue detected. So not only can we see when there is a bug in the code, we can also actually confirm the non-existence of bugs by having these formal verification and assertions on the bounded resources. All right, so let's move back to the presentation again. Thank you. So let's take an overview of the security audits that we do here at BSC and the process that we go through. We always start our audits by doing a framework audit. So based on the project design and the project source, we analyze the functionality implemented on the project level to judge whether there is any unreasonable functionality or any security risk at design level. Then we run the automatic formal verification that we showed, our own developed tool. And we have our security experts here in-house that manually confirm all the results in our automatic scanning. Then we do a complete manual code audit. So this complete manual code audit is a white box going through everything that the client provides to us, all the code, directly source code. And this single step here, the manual code audit is often the only thing that competitors do. So you can see that we have a quite rigorous process here at BSC with added steps to confirm that the smart contract code is secure for our clients. And in this automatic formal verification, we do all of these steps previously mentioned, of course. We do the static scanning, we do the dynamic testing, and we do the formal verification. All the vulnerabilities are reported in the last step to our clients, together with suggestions on how these vulnerabilities can be fixed. And after we have delivered the report, there is sort of a loop and iterations between the client and us, where the client can fix the vulnerabilities according to our feedback and then return the fixed solution to us for confirmation. We see if there is any outstanding vulnerabilities, confirm that the fixes is correct. If there is anything more that needs to be added, we send it back to client again with suggested improvements, and it goes back and forth until the client is satisfied. We split our audits into 3 categories to make it easy for our clients, and that's coding conventions, general vulnerabilities, and business logic issues. And this also makes it easy for the client to divide the workload across their own developers. Here is a brief overview on the results that our clients will receive. Just to first emphasize once more, we have audited more than 2,000 smart contracts. So we are very familiar with the common vulnerabilities that exist in smart contracts, and also experts on the formal verification to make sure that the business logic is correct all over the client's code. So this example here, this table is from the centralized exchange and staking project. So during this particular audit process, we found 11 problems from the business design level to the code security level. And these problems could lead to this complete destruction of the project ledger. It could lead to the loss of user found, and it could lead to theft of the project funds. So this is why a third-party security audit is really necessary to do. And these findings, of course, were reported to our clients with an easy overview on the impact from critical, high, medium, low, and info. And the project, of course, or the whole report includes, of course, a detailed the instruction on how these vulnerabilities can be fixed as well. And just to clarify once more, it doesn't end when we release this report to our clients. We work together with the client after the report to make sure that everything is fixed to the client's satisfaction. And here is also an example on audit service for public blockchains. So we are not only experts on smart contracts, we are also experts on complete blockchain platforms. We have done security audits for more than 50 different public blockchain platforms. An example on projects like that would be Avalanche or Solana. So the actual complete blockchain's core code. The audit reports will differ a little bit on the categories that we report on, and you can see an example here. So if you are a public blockchain that's also looking to have a professional security audit, then feel free to reach out to us as well, because we can provide to you a very rigorous security audit on that as well. And once more, to go back to our advantages and why we are so good at providing security for our clients. As mentioned at the beginning of the presentation, we have secured digital assets worth more than 10 billion USD. So that's something that we should be proud of, I believe. We have audited more than 2,000 smart contracts, and in all kind of different characteristics, for example, decentralized finance, NFTs, GameFi projects. We have one of the world's top security teams. We have the world-leading BSC verification as a service smart contract platform, which I strongly suggest you to test out. It's free to use, so you can find it through our website and try it out. So we are able to provide these professional security audits through both our self-developed tools and through our professional security team to add this manual aspect of the security audits as well. And once again, I'd like to stress that we use this formal verification methodology. The same methodology that is used in critical control systems. Again, as in Mars probe control module and metro systems around the world. And here is an overview of clients and audited projects that we have served. So we are a trusted security company in this blockchain ecosystem. So feel free to reach out to us if you have any security concerns or just want to confirm that your smart contracts and blockchain platforms are secure. We can help you out, and we will be very happy to do so. You can contact us through email, or you can reach out to us through social media, Twitter and Telegram, where you can find the links here. And you can, of course, also find all the necessary links on our website, biosim.com. And I'd be happy to answer any questions that you may have right now as well.
Thank you, Malcolm, for everything. So this session is really great, and we do have a question from YouTube, a viewer named Snaps. Right. I think it's very relevant because I think he's asking for a job from you guys, but that's fine. So I personally have a question. So in your opinion, why do you think even though auditors and audit reports for projects is getting common, the level of exploits and smart contract vulnerabilities has not really gone down since then? Sorry, I think you muted.
That's several aspects to take into that consideration. Well, first of all, the YouTube question asking for a job, feel free to reach out to us. We are growing quickly, and we need more people all across the globe. So if you are interested to join, then send an email, of course. And regarding why companies are reaching out for security audits, but still the number of attacks and stolen funds are increasing. There are several reasons for that. One of the reasons is also, as mentioned in the earlier in the presentation, that we see decentralized finance growing so quickly right now. There's so much money, an increasing amount of money being managed directly by smart contracts. So it's very attractive for malicious hackers to pull together their resources to try to steal these funds. So the incentive is very much there, and it's also relatively easy to confirm whether or not an attack will work or not, because most, or if not all, of the code is already open source. Another reason is the immaturity of security audits in this industry. So as mentioned also earlier, many of the security auditors only do a manual audit on the code itself. And that's not sufficient to find all of these attack surfaces, because these smart contracts are very complex. And the interactions between smart contracts is not always that easy to see. And also, many of these security auditors, they have good expertise from traditional cybersecurity, but that's very different from smart contracts. Smart contracts compile differently than your traditional software. So you really need to have security auditors that are experts in blockchain and smart contracts in order to find all of these security issues. So that's why we are so good at what we do, and we apply this formal verification as well, which our clients so far have been very appreciative of. So most of our new clients is actually from client recommendations. It's clients that are very satisfied with our results and recommend us to new projects that reach out to us. So that's currently the way that we're going fastest at the moment.
Thank you, Malcolm. So I do have another question. I think we have enough time for that. So in this fast-moving space, how do you think projects, auditors, and participants in the space should keep themselves updated with the potential breakthrough with, security risks and all?
I think that's very hard for individual projects to keep themselves updated on security vulnerabilities and security threats. It's really a full-time job for a full security team to be able to do that. I think the best thing that project can do is to do at least frequently security audits, and it doesn't have to be once per week, but it should at least be scheduled security audits. It could be once per quarter or something like that, to keep themselves updated that there isn't any security vulnerabilities. Especially every time their smart contract is upgraded, they should do a new security audit, or every time there is a new Solidity version released, they should make sure that none of the functionalities in the current smart contracts is affected by the upgrades. And that can be done through reaching out to us, of course. They can also run our tool that we have on our website that is free to use. Clients can run that for free every once in a while if they just want to have a quick feedback on the current status.
That sounds good. So, right, I think we are just right on time, and thank you for this insightful session. So, are there any parting words you have for the community?
Thank you so much for this time, and thank you everyone for listening. Thank you for having us on this developer bootcamp, and apologize once again for the technical issues we had 2 times during this presentation, and I hope it didn't disturb too much of your time. Thank all of you.
Thank you so much. Have a good day, guys.